Okay, so example 1 for conic sections. If we take a look at the information that we're given here, we see we've got x's and y's. Only one of those terms, though, is being squared. So this conic section is a parabola. And the first thing we want to do is we want to get this parabola into vertex form so that we can identify all of the important pieces of information and then ultimately graph it. So if you guys think all the way back to last semester when we had that whole parabola unit, the way that we had to get a parabola, the equation of a parabola, into vertex form was by completing the square. So we're going to do that today. The first rule for completing the square was to take everything with a y, because we have y's being squared, keep it on the left-hand side, and we're going to move everything else to the right. Okay, so we're going to keep the term that's being squared on one side, move everything else to the right. So I'm going to move that 3x and that minus 7. That becomes negative 3x plus 7. All right, next step in completing the square, I'm going to factor a 2 out of both of the terms on the left-hand side. The reason is I want to make sure that the coefficient of y is 1 before I complete the square. All right, then we complete the square. We figure out what goes in that blank. Remember, we take the value of b, we divide that by 2, and we square it. So 4 divided by 2 squared is 4. But please remember, we are technically not adding 4 to both sides. We are technically adding 2 times 4. So I'm going to make sure that we add plus 8 to both sides, right? Technically, we're adding that 8 with that 2 times 4, so I need to add 8 on the right-hand side as well. And then what this allows us to do is this allows us to factor that left-hand side trinomial into a perfect square with the 2 on the outside. So y squared plus 4y plus 4. That factors into y plus 2 squared. And then the right-hand side is going to simplify to negative 3x plus 15. All right, we are almost there. The one last thing is this: the coefficient of x also needs to be positive 1 before we've got vertex form. So that means we need to find a way to get rid of this negative 3. The way that I'm going to do that is I'm going to factor a negative 3 out of both of the terms on the right. If I do it to one thing, I've got to do it to both. So we get negative 3 times the quantity x minus 5. And then the very last thing to get that negative 3 on the other side to represent the correct stretch is I'm going to divide both sides by negative 3. All right, final vertex form then is negative 2/3 y plus 2 quantity squared equal to x minus 5. Awesome. So let's think about what we've got. We've got an equation where y is being squared, which means when y is being squared, we're either opening left or right. Now, this parabola has a stretch of negative 2/3. The stretch is negative, which means that we have a parabola that is opening to the left. Now, if we can identify the vertex comes from HK. We always take the opposite sign. So 5, negative 2 is that vertex. That means then the axis of symmetry is the horizontal line, y is equal to negative 2. All right, when it comes to conic sections, oftentimes I'll graph something important before I drop the axes to kind of help me out. We know we have a parabola facing left, so I'm going to plot the vertex first. And then I'm going to drop the axes that make that vertex 5, negative 2. So 1, 2, 3, 4, 5. This would be the x-axis, the y-axis. 1, 2, 3, 4, 5. Yep. And then the x-axis to make that negative 2 would go up here. All right, make a t-table if you choose. I'm going to use a shortcut for graphing a left-facing parabola. Standard left-facing parabola would move up 1, left 1. We are going to move up 1, left 2/3 because we have a stretch of 2/3. And I'm going to reflect that going down as well. Standard left-facing parabola would move up 3, left 9, which is 3 squared. Our parabola is going to move up 3, left 9 times 2/3, 9 times that stretch. So we're going to go up 3, left 6. And then I'm going to do the same thing going down. Down 3, left 6. All right, 5 points. What you need to graph a parabola correctly. That's our first conic section. I'm just going to sketch in that axis of symmetry. And that is it. That is what we're doing on homework. Okay, let's try another. If we take a look at this second conic section, let's see what we've got here. We have x's and y's. This time, both of them are being squared. Now, if we look at the coefficients, both of them are positive and both of them are 2. So we have x and y being squared, both positive, and they're the same. This is a circle. All right, so this is where it gets slightly more complicated. With circles, we're also going to complete the square, but I'm going to reorganize so that I have the x's first and then the y's second. And then we're going to get everything that doesn't have an x or y on the other side. All right, now here's the trick. We are going to complete the square twice. We are going to complete the square for x, and then separate of that, we also have to complete the square for y. So I am setting this up to complete the square. This is equal to 32. All right, if we start with the x's, I factored that 2 out to make sure that the coefficient of x was 1. If I want to complete the square here, that needs to be 4. Again, I take 4 divided by 2 and square it. But technically, remember that we are adding not just 4 to both sides. We need to make sure that we're adding 2 times 4, which is 8. Similarly, with the y values, to complete the square, we take the value of b, which is 8, divide that by 2 and square that. We are going to add 16 there to make that a perfect square. Now again, please remember that we're not adding 16. We are adding 2 times 16, which is 32. Okay, so where do we go from here? Well, I'm just going to clean things up. This becomes 2 times the quantity x plus 2 squared, and then 2 times the quantity y plus 4 squared. And then this is equal to 64 plus 8, which is 72. Now, maybe you guys can see it. Maybe you saw it before we started the problem, but everything is divisible by 2. So if I just divide everything by 2, I can clear out the 2's. Okay, and what that's going to look like is x plus 2 squared plus y plus 4 squared is equal to 36. Now, we're super close. We're not at magnification form yet, and the reason is we have this all equal to 36. To get it to magnification form, we actually need to divide by 36 so that the right side is 1. So in order to get to the right side to be 1, that magnification form, I'm going to divide everything by 36. Here's how I'm going to represent the final answer. X plus 2 squared over, I'm going to represent 36 as 6 squared because that is magnification form if you look back at the last video. Y plus 4 squared over 6 squared. Again, 36 is 6 squared. That is equal to 1. That is the magnification form of this circle. All right, so important information. This circle has a radius of -2, -4. Right, coming from HK. This circle then has a radius of 6. It's the denominator, whatever's in the denominator, being squared. All right, so 6 is in the denominator, it's being squared. That means that we've got a radius here of 6. So just like everything else, I'm going to plot the center first, and then I'll do the axes. So what axis makes this center -2, -4? Well, a y-axis there, and an x-axis here. Okay, and here's how I'm going to graph this circle. We know the radius is 6, which means we go up 6, down 6, right 6, left 6, plot 4 points, and then connect the dots. Okay, so that is right 6, 6, 6, and then lastly, 6 here. Okay, graph a circle. See if I can do this. I am really bad with circles, so I'm going to cheat and use my computer to do that. There you go. Second conic section done. Got our first circle in. All right, very last one that I'm going to do with you guys, and then I will post the answer in the worked out handouts so you guys can check your answer for number 4. But let's do number 3, and then you guys are going to get on with number 4. All right, number 3 looks like this. Last one, let's see what we've got. We've got x and y, both are being squared here, but the coefficients are different. Now, x and y are both positive, but the coefficient of one is 9, and then the other one is 49. So we have an ellipse. This is a case where both terms are being squared. They're both positive, but the coefficients are different. Okay, so very similar to the way that we solve a circle, we're going to complete the square for both x and y. So the first thing I'm going to do is I'm going to get the x's arranged together, and then I'm going to get the y's arranged together, and then I'm going to get rid of the constant. I'm going to move it to the other side. All right, let's complete the square. I'm going to factor a 9 out of the x terms. When I complete that square then, negative 10 divided by 2 squared is 25. All right, I am also going to factor a 49 out of both of the y terms, and so that's going to give me 6y. If 294 divided by 49 is 6. And then when I complete that square, we're adding 9. This is all equal to what we had on the right, negative 225. But remember, we are also adding 9 times 25, 9 times 25, which is 225. That's convenient. And also 49 times 9. 49 times 9 is 441. All right, so I'm going to rewrite this in its factored form. X squared minus 10x plus 25 is x minus 5 squared. And then this becomes 49 times y plus 3 squared equal to 441. One last step to get magnification form. We're going to divide everything by 441 and see what simplifies. So 9 over 441. Let me rewrite this over here. This is going to go to x minus 5 squared over 49, which is 7 squared, plus y plus 3 squared over 9. 49 over 441 is 9, 1 over 9 technically. That's 3 squared, that's equal to 1. All right, that is our magnification form of our ellipse. If we take a look, our circle, or our ellipse, has a center of 5, negative 3. Right, comes from what's inside with x and y. Now here's the deal. Major axis versus minor axis, the vertices and the minor axis intercepts. If we take a look at this equation in magnification form, we see that the number under x is bigger than the number under y, which means that our ellipse is going to be longer along the x-axis than it is going to be on the y. All right, so that's what that tells us. If it was flipped, if the number under y was bigger, that's where we would see an ellipse that is taller and skinnier. So our major axis then is going to be along this line, right? The longer axis. That is the line y is equal to negative 3. It goes through the center. The center value has a y value of negative 3. The minor axis then is then the shorter axis. The shorter axis then is the vertical line that goes through the center. The vertical line running through the center is x is equal to 5. And then our vertices, the vertices for an ellipse are the points at the outer edges along the major axis. So I think it's easier actually to graph the ellipse and then go from there. So I'm going to graph the center of my ellipse, and then again I'm going to drop the axes before I do anything else. What makes that 5, negative 3? Y-axis here. And x-axis here. Okay, and given the information that we've got, that's our center. Now, along the x-axis, the number under x is 7, so we're going to go left and right 7. Okay, and then up and down, that is the y value. The number under y is 3, so we're going to go up 3 and down 3. And then we're just going to connect the dots. So we're going to sketch the curve there with that information. Okay, that's our ellipse. So the last two things are the vertices and the minor axis intercepts. So this is a vertice, this is a vertice, this is a minor axis intercept, this is a minor axis intercept. So our two vertices are the points negative 2, negative 3, and 12, negative 3. And the minor axis intercepts are the point 5, 0, and 5, negative 6. And that is our ellipse. So we've got a circle, a parabola, and an ellipse as your examples. There is one more on this handout, number 4. Give it a try. It's a degenerate conic section. And then the answer, pause the video, give it a try. I'm going to put the answer up. Answer looks like this. It looks a little bit more clear on the website where I've actually posted the worked out handout. The text got a little messed up on this one. But give that a try, and then you're going to do that first homework assignment just the way that we did these 4 examples. Bye, guys.